Hi everyone, welcome to JOANTalks, and I'm your host, Joan Liu. My goal for this podcast is to focus on putting together the knowledge and science relating to your health, fitness, and nutrition that is easily understood and accessible by everyone. Without further delay, this is today's episode. Hi, welcome back to JOANTalks. In today's episode, I will be talking about protein. I am sure by now you have heard a fair bit of information about protein, such as the alternative sources of your protein and do we have our post-workout shakes, etc. I will not be discussing about protein shakes or supplements in this episode. However, my objective for this two-part series is to talk about protein and on the information that we may not know, but we should know. So I will call it what we don't but should know about protein. So what is protein? Proteins are large, complex molecules that play many critical roles in the body, making up thousands of smaller units of what we call amino acids, which are attached in long chains. Now, there are 20 different types of amino acids that can be combined to make a protein. The sequence of amino acids determines each protein's unique three-dimensional structure and its specific function. So then, how do we think objectively about the quality of the protein that we are ingesting? Now, there is a score called the DIAS score, and that in long means digestible, indispensable amino acid score. And it is a method for assessing the quality of protein in foods based on the digestibility of individual indispensable amino acids. Now, the DIAS score was developed to provide a more accurate evaluation of protein quality compared to the protein digestibility corrected amino acid score. The DIAS score takes into account the digestibility of each essential amino acid at the end of the small intestine. Then, what is the practical use for us as consumers? While people like us may not directly measure the DIAS score, understanding its implications can help us to make more informed dietary choices, such as by choosing high-quality protein foods. For example, eggs, milk, meat, and soy generally have higher DIAS scores, indicating that they provide us with good balance of essential amino acids. And it also allows us to make informed choices for our dietary supplements, as information on protein quality, including references to DIAS, can sometimes be found in scientific evaluations of protein supplements. Now, the DIAS score is primarily a tool for researchers, nutritionists, and the food industry, providing a precise measure of protein quality. Consumers can benefit indirectly from DIAS through improved dietary recommendations and food products formulated for optimal protein quality. On top of that, when we look at a protein, there are two factors that determines the protein quality score. And that is, 1, the composition of the 9 essential amino acids, and 2, what is the bioavailability, which means how well do we digest and absorb that particular protein. Now, each of us, our bodies have a requirement for 9 essential amino acids and organic nitrogen. So this translates into the fact that we can make 11 amino acids, but the 9 of them we have to get it from our diet. The digestion and absorption of protein is usually 95% or higher for all animal proteins. Now, as for plant proteins, it is less, maybe only about 60 to 70% available, because we cannot digest the fiber proteins that are attached to it. So my point is, for a plant, the protein is there for a purpose and simply is for the plant itself. The protein is attached to the fibers, and it is these fibers that makes the structures. The plants have proteins attached to the stems, the leaves, the roots, the flowers, the seeds. And when you eat the plants in raw form, only about 60 to 70% of the protein is available because we cannot digest the fiber. We can ascertain that a whey protein isolate is 20% better than a soy protein isolate on the basis of its essential amino acids. An American researcher, Don Layman, says we should think of protein as a vitamin pill. So what he meant was we don't have a daily requirement for a vitamin pill, but we do have a requirement for the 12 vitamins inside the pill. We don't actually have a daily requirement for protein, but we have a requirement for the 9 or 20 amino acids inside of it. In terms of protein requirement, we have a requirement for the 9 essential amino acids. These amino acids are essential building blocks for new protein, and every one of them has a metabolic role, such as leucine and mTOR, arginine and nitric oxide, lysine and carnitine, and even cysteine and glutathione. So that being said, generally, when people think about such as vitamin C, we know that there is a minimum recommended dietary allowance to prevent things like scurvy, but people will tend to take 5 to 10 times more, especially during COVID times, just for immune response. However, somehow we just resist thinking the same way about amino acid, but it should be the same. An amino acid looks a bit like a fatty acid. It has a carboxyl end connected with a carbon, and it has a nitrogen end. I will attach the diagram of the generalized structure of an amino acid in the description box on my YouTube channel. All of the 20 amino acids are different. They go into proteins, form different structures, which can be simple like insulin with 51 amino acids, or it can be myosin with thousands of amino acids. Every protein in the body has different turnover rate. Some of them, like insulin, may last 15 minutes. Some of them, like collagen, may last several months or even years. By now, we should know that it is very important to ingest enough protein in our daily diet. And that's the challenge. When I look at my clients, when I evaluate their nutrition, almost without exception, I conclude they are not getting enough amino acids based on how much protein they are consuming. Each day, we have a recommended dietary allowance, and that is the RDA in short. For the RDA, the argument is that we test the population and come up with an average number and add a safety factor of 2 standard deviations, which supposedly would be adequate for 97.5% of the people on this average to prevent any signs of inadequacy. But that also means 2.5% of the people are actually deficient even at that level. But how did the RDA originated? Historically, humans began to evaluate protein needs in the field of animal science back in the early 1900s, before we even knew what were essential amino acids. That time, farmers wanted to know how to get animals to grow at its best. They developed protein quality scores and things like that to track how much growth for what they fed the animals. They looked at how much nitrogen was deposited for the amount that was fed, and hence the concept of nitrogen retention, and that's what we call the nitrogen balance. And that's how we determine the protein requirement. We will continue more on this topic in the part 2 of this series on what we may not know but should know about protein. If you have not subscribed to my podcast, please subscribe it now so you will get notified when the next episode is out. I see you on the next episode. Bye.